GFI receptacles, ground fault circuit interrupters, and dimmers typically take up more room in electrical boxes compared to standard devices such as switches or single-pole receptacles. This increased volume is attributed to several factors. Firstly, electronic components are a primary reason. GFI receptacles and dimmers contain additional electronic components that require more space. These may include circuit breakers, transformers, and heat sinks. Secondly, internal connections also contribute to the increased size. These devices have more internal connections, including wires and terminals. GFI receptacles and dimmers are not marked with volume or counted as 4 conductors for several reasons. The National Electrical Code, or NEC, does not require volume marking or counting of conductors for GFI receptacles or dimmers. Typically, these devices have only 3 current-carrying conductors, which are the line, neutral, and ground, as well as an additional bare ground wire for equipment grounding. The additional internal components within GFI receptacles and dimmers are not considered as additional conductors. They are part of the device's functionality and are not counted as separate wires. When installing GFI receptacles or dimmers, it is important to consider certain installation factors. Ensure that the electrical box is large enough to accommodate the increased volume of the device. If necessary, additional knockouts may need to be created in the box to allow for the larger wires and internal connections. It's crucial to follow the manufacturer's instructions carefully for proper wiring of these devices to ensure their safe and reliable operation. To reiterate, GFI receptacles and dimmers take up more space than standard devices due to their internal electronic components and increased number of connections. Despite their larger size and complexity, they are not marked with a specific volume nor counted as having 4 conductors according to the NEC. Let's delve deeper into the reasons why the NEC doesn't require GFI receptacles or dimmers to be marked with a specific volume or counted as 4 conductors. Firstly, the code focuses on the number of current-carrying conductors present in the box, not the internal components of a device. GFI receptacles and dimmers, despite their internal complexity, typically only have 3 current-carrying conductors plus a grounding conductor. These are the line, neutral, and ground wires that connect to the circuit. The internal components, while essential for the device's operation, are considered part of the device itself and not additional conductors that need to be accounted for in box fill calculations. Secondly, the NEC provides specific guidelines for calculating box fill based on the number and size of conductors, device yokes, and equipment grounding conductors. These calculations ensure that there is sufficient space within the box for proper heat dissipation and to prevent damage to the wires or devices. The NEC existing box fill calculations are deemed adequate to accommodate GFI receptacles and dimmers, provided that the appropriate box size is selected based on the number and size of conductors entering the box, as well as any device yokes present. Thirdly, the NEC is a performance-based code, meaning it sets minimum safety standards but allows for flexibility in design and installation methods. The absence of specific volume markings for GFI receptacles and dimmers does not imply that box fill calculations are unnecessary. It simply means that the existing box fill rules are considered sufficient to ensure safe installations. Installers are still responsible for selecting appropriately sized boxes based on the number and size of conductors and devices present. Fourthly, the NEC undergoes regular revisions and updates to incorporate new technologies and address emerging safety concerns. If, in the future, it is determined that GFI receptacles and dimmers require additional box fill considerations, the NEC may be revised to include specific requirements for these devices. However, as of the current edition, the existing rules are deemed adequate. When selecting an electrical box for GFI receptacle or dimmer, it is essential to consider several factors to ensure a safe and compliant installation. 1. Determine the number and size of conductors entering the box. This includes all current carrying conductors, neutral conductors, and equipment grounding conductors. Use the NEC tables to determine the volume occupied by each conductor based on its size. 2. Account for device yokes. Each device yoke, such as a GFI receptacle or dimmer, counts as 2 conductors based on the largest conductor connected to the device. This is because the device takes up space within the box and displaces the conductors. 3. Consider the volume occupied by equipment grounding conductors. The NEC allows for the equipment grounding conductors to be combined into a single conductor for box fill calculations based on the size of the largest equipment grounding conductor. 4. Calculate the total box fill. Add up the volume occupied by all conductors, device yokes, and equipment grounding conductors. This will give you the total volume required for the installation. 5. Select an appropriately sized box. Choose an electrical box that has a volume equal to or greater than the total volume calculated in the previous step. Ensure that the box is listed and labeled for the intended use. 6. Consider the box material. Electrical boxes are available in various materials such as metal and non-metallic. Choose a box material that is suitable for the environment and application. Metal boxes are typically used in commercial and industrial settings, while non-metallic boxes are commonly used in residential settings. 7. Inspect the box for damage. Before installing the box, inspect it for any signs of damage, such as cracks, dents, or corrosion. Do not use a damaged box, as it may not provide adequate protection for the conductors and devices. 8. Install the box properly. Follow the manufacturer's instructions and the NEC requirements for installing the electrical box. Ensure that the box is securely mounted and that all knockouts are properly closed. 9. Make sure to properly wire the GFI receptacle or dimmer. Follow the manufacturer's instructions and the NEC requirements for wiring the device. Ensure that all connections are tight and secure. 10. Test the installation. After completing the installation, test the GFI receptacle or dimmer to ensure that it is functioning properly. This can be done using a GFI tester or by simulating a ground fault condition. Here are some additional considerations for installing GFI receptacles and dimmers. Firstly, when replacing an existing receptacle or switch with a GFI receptacle or dimmer, it may be necessary to upgrade the electrical box to a larger size to accommodate the increased volume of the device. Secondly, when installing GFI receptacles in damp or wet locations, such as bathrooms or kitchens, use weather-resistant GFI receptacles and weatherproof enclosures. Thirdly, when installing dimmers, ensure that the dimmer is compatible with the type of lighting fixture being controlled. Some dimmers are not compatible with certain types of LED or compact fluorescent lamps. Fourthly, when installing GFI receptacles or dimmers in multi-GaN boxes, carefully plan the layout of the devices to ensure that there is sufficient space for all conductors and devices. Fifthly, when in doubt, consult with a qualified electrician. Electrical work can be dangerous, and it is always best to seek professional help if you are not comfortable performing the work yourself. Now let's consider specific NEC articles that relate to box fill calculations. NEC Article 314.16, which is titled Number of Conductors in Outlet Device and Junction Boxes and Conduit Bodies, provides the rules for calculating the number of conductors permitted in a box. This article specifies the volume occupied by different sizes of conductors and the rules for counting device yokes and equipment grounding conductors. NEC Article 314.17, which is titled Conductor Fill, provides additional rules for conductor fill in boxes, including the requirements for using box fill tables and the restrictions on exceeding the maximum number of conductors permitted in a box. NEC Article 406.4, which is titled General Installation Requirements, contains requirements for the installation of receptacles, including GFI receptacles. This article specifies the requirements for receptacle spacing, mounting height, and protection from physical damage. NEC Article 404.2, which is titled Dimmers, contains requirements for the installation of dimmers. This article specifies the requirements for dimmer compatibility, wiring methods, and grounding. Let's discuss the importance of proper box fill calculations. Proper box fill calculations are essential for ensuring the safety and reliability of electrical installations. Overfilled boxes can lead to several problems, including firstly, overheating. Overcrowded conductors can generate excessive heat, which can damage the insulation and lead to short circuits or fires. Secondly, damaged conductors. Tight bends and excessive pressure on conductors can damage the insulation and reduce the lifespan of the wires. Thirdly, loose connections. Overfilled boxes can make it difficult to properly tighten connections, which can lead to loose connections and arcing. Fourthly, code violations. Overfilled boxes violate the NEC and can result in fines or rejection of the installation. In addition to the safety concerns, proper box fill calculations also improve the overall performance of the electrical system. Properly sized boxes provide adequate space for heat dissipation, which helps to extend the life of the conductors and devices. They also make it easier to perform maintenance and repairs, as there is more room to work within the box. In summary, GFI receptacles and dimmers do take up more space in electrical boxes than standard devices due to their internal components and connections. While the NEC does not require them to be marked with a specific volume or counted as 4 conductors, it is still essential to perform proper box fill calculations to ensure a safe and compliant installation. By following the NEC requirements and the manufacturer's instructions, you can ensure that your electrical installations are safe, reliable, and code compliant. Always prioritize safety and consult with a qualified electrician if you have any doubts or concerns.